Now we're going to look at linear functions. I'm sure you're familiar with straight lines. This is the function where they come from. A linear function can be written as f of x equals mx plus b, where m and b are numbers. The x stays the letter x. F of x stays as f of x. The graph is a straight line through the point 0b. So if x is equal to 0, m times 0 is 0, and we're left with f of x equals b, or y equal to b. M is slope. Slope is also equal to average rate of change over an interval, and we'll call this interval from x equal to c to x equal to d. So our letter x goes between c and d. Slope is also change in y, or f, or output, over change in x, or input. To represent the words change in, we can use delta, delta y, over delta x. You can also call it rise over run, which would mean vertical change over horizontal change. Or if we talk about 2 points, the change in y would be y2 minus y1 over x2 minus x1. And using the function notation with our point where x ranges from x equal to c up to x equal to d, the difference in the two x's would be d minus c, so that the y value associated with d using the function notation is f of d minus, and the y value associated with c would be f of c. We'll be using all of these notations and more as we study more about linear functions. When we talk about slope, slope could be a positive number, a negative number, 0. So let's think about the lines that go with that slopes. If m is positive, my line, we read from left to right, a positive slope would go up. So my line would increase. If m is equal to 0, it doesn't go up and it doesn't go down. It's horizontal. Horizontal line. If the slope is negative, m is less than 0, again reading from left to right, it goes down, so it decreases. Let's look at a picture to see if we can put these words in our picture. Here's my line. X's and y, or f of x. And there are my points C and D. These points could also be called x2 and x1. This x, you'll note, horizontal is the input into the function. this value for C on the f of x axis could be written as y2, or it could be written as f of, that's y1, because it's associated with x1. Or C, so y1 is f of C. For D, that would be y2 or f of D. So we find the slope by doing the vertical change, the difference in the y's, over the horizontal change, the difference in the x's. Now let's look at an example. The question that we're asked to find in this application problem about clocks is what is the cost per clock? It also tells us that there is a linear relationship between the cost and the number of clocks produced. So let's let C equal the cost and let N equal the number produced. If I want the cost per clock, and I think about it as a linear relationship, what I'm looking for is that the cost is on top of a fraction and the number of clocks is on the bottom. So that I want my slope M for my linear relationship to be change in cost divided by change in number of clocks. So if I set up the information about the actual dollars and numbers of clocks from the problem, I need to set my pairs to be ordered. N is like X, it's in the denominator. C is in the numerator like Y, so my pairs have to be set up as N first and then C. So I was told that for 4 clocks, it was going to cost $1,080 to produce all 4. And for 40 clocks, it was going to cost $1,800. For a linear relationship, you think line. So we're thinking, when we said M, y equals mx plus b, or f of x equals mx plus b, and I need to find my slope. So m is equal to, in the denominator, I have the change in the number of clocks. So that will be 40 minus 4. In the numerator, I need the y value or the cost value that goes with 40. So that's 1,800 minus the y value for 4 is 1,080. When I subtract 1,800 minus 1,080, I get 720. 40 minus 4 is 36. So this is equal to 20. Now, I'm thinking about finding a linear relationship. But let's go back and see what the question asked for. The question said, what is the cost per clock? When I reduced this and divided 36 into 720, I got 20. But I think about it as dividing 36 into the numerator, I get 20. 36 into the denominator gives me 1. Remember that 20 is the cost, so that's $20. 1 is the number of clocks. So this is $20 for 1 clock. So the cost per clock is $20. I don't need to get the whole linear relationship to answer the question. I just need to find the slope.